activated.
Hello, I'm Dr. Somara, a mechanical engineer and broadcaster.
I'm Dr. Simon Clark, a physicist and science communicator.
Over the last 4 decades, the internet and advances in connectivity have revolutionised the world around us.
And as the technology becomes smaller and cheaper, more and more devices are joining the so-called Internet of Things.
Toothbrushes with Bluetooth, fridges with Wi-Fi, AI-powered toasters.
But some things, like skills and experience, can't be downloaded, streamed or shared quite so easily. Or can they?
With networks, robotics, VR and haptics, we now have the chance to transcend our physical boundaries and step into a very different place and time.
So is it time we stopped talking about the Internet of Things and started talking about the Internet of Skills?
Welcome to Mission Responsible.
Shinny, what skills do you think you've learned so far in your spy activities and your training?
The skills I have learned is that I'm terrible at spying.
Not sure I'd class that as a skill. I think it's great that you've recognised it.
It's a skill to have self-awareness.
Yeah, okay, so you've learned self-awareness.
Thank you.
You know, you could have said abseiling, rappelling, controlling guard dogs, dancing, poker, mixing cocktails.
It sounds like we are both having very different spy experiences.
Yeah, just because I can say all those things doesn't mean I know how to do any of them. I have tried those on recent missions and they have all been disasters.
Coming up in this week's episode.
So I really started that vision of building an internet which would allow us to transmit physical skills, touch and haptic muscle movement through the internet.
Second of all, whenever you do use the robot, make sure you don't slam down,
I could actually be like an octopus.
Yeah.
I mean, wow. So Simon, as a YouTuber, are you already part of the Internet of Skills?
I'd never thought about that before.
You're not transferring your many skills onto other people through YouTube?
I suppose in a way I am. I'm not sure that I'd say I'm part of the Internet of Skills. I mean, one of the things that I try to do with all the things that I make is teach the scientific method and the methodology of how you go about solving a problem and how you go about analysing data and all that kind of thing. And I suppose that means I'm part of the Internet of Skills, but I think of myself as an overexcited nerd who just likes talking about things. And I'm not sure I would say that's a positive skill to pass on to anyone else.
Right. I mean, I think my inner spy is telling me that the Internet of Skills is something very different from education.
Yeah, like when I think of education and educational YouTube, it's quite academic. Whereas when I think of skills, it's more practical. It's almost more vocational.
Yeah, it's like learning to play an instrument without sort of getting the theory.
Yeah, if I was doing music lessons on YouTube, or I was teaching people to play the piano, I could maybe say, yeah, maybe I am part of the Internet of Skills. Whereas if I was doing like music theory, I wouldn't think of it in that term.
Why don't we switch to the space age briefing terminal and see what today's mission is?
Scanning. Login accepted. Access granted.
Welcome, agents. This week, your mission, should you choose to accept it, is to explore responsible engineering and how it can unlock the Internet of Skills.
I'm so much looking forward to finding out what Internet of Skills is.
Agent Clark, your objective is to track down the man behind the iOS and learn about his research.
That's going to be tough because that guy's going to have skills on absolutely everything. He's going to know how to avoid me.
Agent Somara, your mission is to locate the clandestine research centre in the heart of London, developing one of the world's most advanced teleoperation technologies.
Teleoperation. That's a long word.
Hopefully my inner spy skills will help me to pronounce it.
Briefing complete. Good luck, agents. This message will self-destruct in 5.
Wait, before you go, is there any way you could teach us how to make you not explode?
1.
I think we'll still need to learn how to do that.
So while Shinny goes and finds a dictionary, I've been narrowing down who my target is. It's not Zuckerberg, it's not Gates, and it's definitely not Musk. So someone who has actually changed their haircut since high school. According to the bods down in research, our best bet is one Mischa Dohler, PhD, FIEEE, FRA, ENG, FRSA, FIET. I'm no expert, but that's a weird way to spell his name. According to his file, Mischa is an award-winning top 1% global innovator, the vice president of emerging technologies at Ericsson, the co-founder of 5 companies, composer of 5 albums, and the speaker of 5 languages. That's quite an impressive CV, but like Alexa, I bet he still can't follow a Scouse accent.
Hologram programs activated.
Mischa, can you start off by please introducing yourself and tell us what you're passionate about?
Hey, Simon. Good to be on the show here with you. Yeah, I'm super passionate about music. I'm super passionate about technology. And I've been doing quite a bit of that in my life before. So I've been dealing a lot with pioneering a lot of stuff in the telco sector. Trying to come up with new forms of the internet. And at the same time, originally I would become a professional musician, a pianist, kept composing over the years. So I've been keeping my music side alive as well. There's
often a link, isn't there, between people who are very passionate about science and engineering and technology and music. I mean, why do you think that is?
You tell me. I'm not. There might be a correlation, but I'm not sure there's causality. To be honest with you.
Spoken like a true scientist. Can you explain what the Internet of Skills is?
So, in about 2015, when I was at King's College in London, I was really thinking, what's going to be the next internet? We had just done that Internet of Things. Before that, we were able to connect all mobile phones. We've done the mobile internet. Before that, the fixed internet. So I was looking at what's going to be the next thing. What can I connect? And I thought skills is really what I'd love to do because, we are able to transmit video and audio through the internet, but I can't really touch through the internet. I can't really move objects. I can't teach you how to play the piano. You can't teach me how to paint. So I really started that kind of that vision of building an internet which would allow us to transmit physical skills, touch and haptic muscle movement through the internet. And, I've been working on this now for the last, 10 years. A bit of an outage now moving to Silicon Valley, but retaking that entire subject now, I think it's just really exciting.
The Internet of Skills has the potential to truly reshape our world. Alongside sharing our skills and experience, an Internet of Skills could greatly expand people's ability to work remotely, reducing travel and, ultimately, carbon emissions. The technology could also help create and support more sustainable cities and communities, help provide responsible consumption and production habits, and has applications for use in providing medical care and disability accessibility. As I understand it, the genesis of this idea has something to do with surgery. Is that right?
So I did start with a very generic vision. I really wanted to democratize kind of the skills. I wanted to democratize education. I was really after that, and then I was very very much after use cases, and that's what I learned with my companies. Often we come up with ideas, but we never validate that with society, with the markets, and all that. So I started to reach out to different what we call verticals, and one of them is the healthcare vertical, simply because King's College has 4 hospitals, and I thought probably they're going to use it. So I started to talk to a surgeon, Prakash Gupta, who is, one of the world's leading robotic surgeons, and he pioneered that whole field or co-pioneered that. And what he does is he looks into a viewing port whilst he's doing the operation and actually manipulates a set of robotic controls, which then do the operation in the human body. Why do we do that? Because like this, rather than cutting everybody wide open, you just have a little insertion hole and it's super precise. There's no blood loss. People, patients go home within 24 hours. So it's a very interesting technology. The one thing, though, he can't do is he can't do it remotely, or he couldn't do it. And so we started to really pioneer this field of remote robotic surgery using 5G, because 5G is very low latency. So we just put a few of the constituents together and worked around that concept. He loved it. He really loved it. And, in the meantime, the field has really moved on.
Realizing the full potential of the Internet of Skills requires a number of technologies to work together in tandem. Haptic technologies, those that transmit a sense of touch, have seen major developments in recent years, with a focus on wearable devices, allowing users to feel force, motion, and texture. But a good quality haptic experience requires latencies below 10 milliseconds, meaning that fiber broadband and low latency 5G networks need to be readily available. So the latency point is crucial, right? Because that's giving you feedback. If you're a surgeon, you need to, if you're making an incision, feel the right level of resistance.
Yeah, absolutely. So, and that's really the magic. So we as human beings are kind of geared towards very low latency engagements. Something, 20 milliseconds, we would probably not feel that, there's a remote connection. So we kind of had this big challenge to get everything done with 20 millisecond round trip time, right? So Proca moves his essentially, gear. It would transmit that remotely, would then execute the operation, and the haptic feedback would come back to him to tell him he has been successful in doing that operation. So 20 milliseconds is not a lot of time, right? So and therefore, doing all within that budget is actually really the big engineering challenge, and a bit of magic has happened there too.
So from a network perspective, the latency is there, the bandwidth is there. Is the hardware there? Is robotics dexterous enough that a surgeon in London could operate anywhere in the world?
So anywhere in the world, the answer is no. And that is yet related to, how we have this, physics. Oh my God, so limiting. Speed of light. You will have heard about this, if we could just go quicker than this speed of light. But that's our limiting factor at the moment. But, truth is that from a robotics point of view, we can do a lot of things. It's pioneered really robotic surgery by a company called Innovator who did the Da Vinci robot. A lot of new gear has emerged over the last years. I think we're able now to do a lot of stuff over large distances, but it's yet the networking side which gives us that limit. But having said that, if you're a surgeon in London, Proca is, doing his operations in London, he can operate in the whole UK, large swath of Europe, probably parts of Africa, even in the US. We could really look into the rural areas of the United States. We could probably also reach parts of South America. So I think if we have strategic hotspots of hospitals with high-end surgeons, then we would be able to really kind of democratize that robotic surgery access to populations which normally do not have the means of actually traveling to these, to the capitals of the different countries.
So the pesky speed limit of the universe, the speed of light aside, the limitations are presumably also how much feedback a surgeon can get in terms of your haptics and in terms of how precisely you can actually manipulate the scalpel, whatever instrument it is that you're using.
Yeah. So you know a lot about this. How is that? It's amazing. So no, it's exactly the issue. So so currently robotic surgery works just with a screen. So they just see essentially what they're operating on, and I think the next generations give already a little bit of haptic feedback. If you drive, let's say, when I drive my Tesla and I'm going over a line without indicating, it would vibrate. So I'm getting a vibrational feedback. At King's back then, we introduced that notion of a haptic glove. So the idea was to give a haptic glove to Proca, which would actually reproduce, a sensation, certain sensations to different fingers, depending on what he was cutting. So if he was cutting just muscle tissue, it would maybe just the ring finger would vibrate. If it cut the, let's say, a sinew or an artery, it would be something else. So you would get a haptic feedback, which maybe would not really correspond to the haptic feedback you get when you actually do that, in situ. But it was good enough for them to understand, they're cutting different tissues, which apparently there's a huge difference between cutting an artery and the muscle. So, yeah.
Well, it certainly sounds like the hardware is almost, if not at the point where it is usable over large distances. And to press you, I mean, you said about possibly having local hubs with this high-end technology that then operate over regional areas. When do you see that becoming commonplace? Is that in the next couple of years?
I think it's happening now already, Simon. It's I've seen actually. I started to work with another surgeon, Vipul, who's based in Miami, but often on the West Coast, and He told me the other day he operated over a distance of about 1,000 miles, using commercial gear. So we're getting now in an age where if the hospitals are ready to adopt the gear, and or governments say we have to start installing that to help our underserved population in the country, I think the technology ecosystem is game. We're ready to deploy that.
And do you think that by removing the need to travel to someone and see them face to face, and you can effectively have an approximation of touch at great distance, do we lose something as humans by not engaging directly face to face, but having that facsimile of contact?
That's a brilliant question. I'm not sure I have an answer for that, but the way how we thought about this specifically when it comes to healthcare applications is that the patient would not walk into an empty, cold hospital where they have to, lay down on a table and then being operated by a robotic device. There will be nurses, there will be human contact, there will be warmth, there will be really that emotional bond, which I think patients are looking for when they're going into these really vulnerable operations. The only thing we are outsourcing is the truly, world-class, high-skill surgeon, which simply cannot be in the rural area at any time. So it's the only thing we are outsourcing, if that makes sense.
And do you know how, or have surgeons said to you how they feel about not being present? I mean, do the surgeons feel like they're missing out on something?
The feedback I got actually from my very limited feedback, I have to say, I got is they don't really mind, because whilst they're doing the operation, they're actually in the viewing port. So whether they're viewing through, the viewing port just about maybe 2 meters where the patient is just next to them, or they do it for a large distance, really doesn't make a difference. What they want to experience is that immediacy. They want to have the reliability. They want to know that the patient is cared for. This is what they really care about.
And then final question, what are you allowed to tell us about what you're currently working on at Ericsson?
So at Ericsson, we do a lot of really interesting things at the moment. I'm based now, I left London about 1.5 years ago, and I live now in Silicon Valley. Everybody in Silicon Valley at the moment talks about, of course, generative AI. When they don't talk about generative AI, they talk about augmented reality and virtual reality. So these are kind of the 2 or 3 bubbles of tech which is evolving. So I'm involved, with the local engineering team. We do a lot of the native integration of 5G into these emerging, VR and AR devices. And we feel this is really needed to kind of build a very immersive internet, an internet which isn't two-dimensional as we just experience it, today. We want something which is truly spatially aware and starts to give us, abilities we haven't seen before. So this is what I'm part of, and it's a lot of fun. It's a lot of challenges, and I'm learning a lot of stuff, and hopefully you will be able to use that maybe in 12, 24, 36 months' time.
Mischa, thank you so much for joining us and for sharing all of your expertise.
Pleasure being with you, Simon. Have a good day. Thank you. Bye.
Data transfer complete. Hologram program deactivated.
Wow, the Internet of Skills truly sounds like it has huge potential. But just like opening more than 8 tabs in Chrome, you're going to need some seriously powerful tech to make it work. I wonder if Shinny's found something that can help the journey of turning the concept into reality.
I've decided to head to Oxford Street in central London in order to look for some advanced teleoperation technology. As every good spy knows, these high-tech places typically use a front business to throw you off scent. But I was determined to hit up every luxury boutique and every 5-star restaurant until I found them. 5 handbags and 6 slap-up meals later, and no joy. My producer is on the phone to the bank, and I've had a tip-off about a robotics company operating near Kentish Town. Time to check it out. So we're outside Spectrum House, which is where Shadow Robot is, and I'm very curious to know what their offices are like, because this is quite a funky area. Would never have expected advanced technologies to be located here, so let's find the doorbell. As I approached the target building, I could immediately see I was going to have to gain access using some advanced spy techniques. Hello? Anyone there? Can you let me in?
Now chocolate.
It was clear from the tech in the room and the quality of the refreshments that I was in the right place.
Down there, because whenever you press this button over here, that will activate the robot, and however you move with these gloves, the robot will replicate, right? So that's number one. So careful with the pedal. Second of all, whenever you do use the robot, make sure you don't slam down. Be aware when you're pressing it, because whenever you do and you have the gloves on, if you want to rest and you're pressing the pedal, that means the robot will also go down, right?
Okay.
Once you've put the gloves on, I will also have a look at everything, and the only advice I have is also start slowly and try to build your confidence as you go.
The pedal is speed controlled depending on... It's like a gas pedal.
No, it's not even gas. It's as much of a clutch. It's either on or off.
Oh, okay.
You press the pedal, the robot works. You let go, the robot doesn't work. Okay, so if you give me your hands right now, I will have your hand, this one first. If you can do this for me. I'll put this here. So now try to mimic the position of these hands over there. So sort of like that, yeah. A little bit back, because remember, you have to be in the sight of the vibe trackers.
Wow. Gosh, there is no latency.
Between these two, no. So can you do...
Literally, the movements I am doing, the robot is reacting almost immediately. I've just turned my wrist. I've done a peace sign.
I can also tell that you're right-handed. From the fact that you are completely leaving your left hand.
Yeah. Gosh, I'm trying to pick up a wooden block with my thumb and forefinger. To get the answers I wanted, I needed to speak with the top brains on the project. It wasn't long before I was able to track them down.
Hi, I'm Rich Walker. I'm one of the directors of the Shadow Robot Company.
Rich, what a fantastic experience to be wearing the sensors and to have a go with the Shadow robot. How did this all come about?
Firstly, thank you for saying such nice things about it. It's great to see people kind of engage with this sort of technology and really get a feeling for what we're doing. Shadow has been trying to replicate the human hand for a very long time. So we've spent over 25 years building robots like human hands. And the idea here is that for a robot to be useful in the world, dexterity is kind of what we use to be useful in the world, so the robot probably wants a hand like ours. And the system there is the culmination of that. We take your hand and we track the movements of your hand and we map that across into the robot hand to give it the same movements as you have.
And I didn't experience much latency. It was pretty astounding how a movement of mine almost instantaneously was responding in the robot. What kinds of latencies are we talking about?
So there's no kind of inherent delay in the system. The only lag comes from the mechanical speed the robot moves at. We don't have it accelerating very, very fast, because when things accelerate fast around people, we tend to react badly to that. We jump away, we become unhappy. So the robot moves in a kind of not sedate, but not high speed. So when you make small hand movements, when you're making little gestures, you'll have seen the fingers moving pretty much at the speed you're moving at. It's really hard to spot any latency there.
Why is this technology so useful? It's impressive, but where will it be applied?
So there's a couple of ways this technology becomes really interesting. One is that you can capture human skills. So if you're doing something in machine learning, deep learning, AI, a lot of the time what you want is data that says, how do we do this task? So you can then learn from that. And a system like this lets you say, we'll have a person do this task, capture the data, record it, and then we can learn from that. But the other is much more obvious. You could put that robot somewhere that you don't necessarily want to be. That might be the other side of a perspex barrier where there's something noxious. That might be the other end of a very long phone cable because there's something a long way where you want to be at. We've talked to people who are doctors who are looking at the idea that you could use this for remotely diagnosing patients. You could put one of those in a clinic somewhere and a doctor could sit in an office somewhere else and look at the patient and kind of do diagnostics. So not surgery, but actually the much more common thing of, pulling on someone's eyelid and looking at their eye and kind of tapping their knee and checking it's okay. So anywhere where you want to put put a person, but it's hard to get them. There's an opportunity to put a set of robot hands instead. And we think that's very exciting.
The technology that I sampled it does seem very mechanical, almost a way of relaying instructions. Is there this idea that you may develop it to be more experiential?
So we have done systems in the past where you have more of your sensors are engaged. There's another set of gloves that give you touch feedbacks, that give you the actual feeling that's coming from the robot fingertip on your fingers. That's pretty impressive. They're a little bulky, a little bit harder to wear, so we tend to use this system when people are first trying it. It's also possible to use a system like this with a headset and then a remote camera, so you're seeing from somewhere where the robot is. You were seeing the problems of depth perception because you were 2 meters behind the robot or behind where the robot hands were. If you have a headset and a camera, then suddenly you're right up close with the robot. The drawback with the headset is you can't see what's going on around you. So if you're in a confined working area, it can get a little bit tricky. So we tend not to use a headset for this sort of demonstration, but that is possible. And then there are people looking at even more interesting ideas. We've talked to people about a sense of smell. How do you get the smell from one end to the other? And of course, hearing is really, really important. Putting a microphone at the place you're working and relaying that back to you can give you that moment where you touch something and there's a little, as the fingers touch on something, and you could hear that and go, aha, I know what's happening.
Tell me about you, because this is such fascinating technology and there's so much potential for further advancement. How did it all begin?
So Shadow has a kind of unusual history for a technology company. We actually started out as a bunch of people meeting in someone's attic once a week, having fun building robots. We were really interested in building robots, and so that's what we did. It was kind of a little robot club almost. From that, we grew a company because we realized we actually had a set of skills that were valuable to people, and people were saying, hey, can we pay you to do this? Can you make something for us? Can you develop some hardware for us? So that got us into the business of robotics technology. And over the last 25 years, we've grown from that into a thriving company that sells state-of-the-art robots all over the world to people doing the cutting edge in robotics research.
And what kind of industries are you helping?
So this technology gets a lot of interest from people in areas like pharmaceutical manufacturing, in things like nuclear engineering. And there are people who are looking at it for advanced aerospace applications. Essentially, anywhere you have a really key set of skills and a challenge in putting someone to work using them. Maybe they have to wear protective equipment. Maybe they have to travel. Maybe it's just an unpleasant job to do, and you want to get the person out of that job.
So as an engineer, I'm sure you've experienced countless problems along the 25 years. What are the current challenges you're facing?
It's interesting that the hardest problem in this kind of robotics is actually packing things together. It's you don't quite take on board how much the human body does with all of the parts that are in there. And when you try and replicate that in a machine and a mechanism, you suddenly find yourself saying, oh, well, hang on, the only way we can build that is with something this big, but in the human body, it's 10 or 100 times smaller. Oh, okay, so we're going to have to compromise on that. So working out ways to pack everything together and retain the kind of strength and quality to give it the reliability you need for it to be useful. So it's not just a kind of delicate thing that works once. It's something that you can keep using again and again. That's, I think, the real challenge here.
So what's next for Shadow Robot?
So it's a continuous process of redevelopment and reinvention of the hardware. We sit there and we say, how do we make this perform better? We're using a human to control it. We're getting the data from that human in a way that we can use to learn to do things. So we're going to see some very interesting things start happening as we start to plug in some of the recent advances in kind of AI technology, all this deep learning and transformer technology that we're seeing. That will make a big difference in terms of what the system can do from a software point of view. But then also we want to advance the hardware capability. We want a better sense of touch. We want more precise movements. We want better sensors in there. So that's always a continuous process of development.
So in terms of the Internet of Skills, how does this kind of technology fit into that?
So this technology is interesting because it lets us transfer skills from one place to another. You can be in London and do a piece of work in Chicago. And you can do that in real time. You saw there was very little latency when you were here. We've done experiments from London to San Francisco where you couldn't really notice the latency in the robot even there. It was about 150 milliseconds. There was more latency in the video call we were using to see what was going on than there was in the robot movement. So this gives us a way to transport skills around. And of course, once you can transport the skills, then you've got the opportunity to deploy them anywhere and of course do that learning.
So it's a highly exciting field. If anyone wanted to get into it, would they study something like mechanical engineering, or is it better to learn how to code?
I'd say it was always worth learning how to code, but I'm biased because I learned how to code at a very, very early age. And it's always been useful. I think that for an area like robotics, what's interesting is how multidisciplinary it is. If you're just a mechanical engineer, you get stuck very quickly because you can't make the design choices around electronics that you need to, and you can't make the design choices around sensing technology that you need to, and you don't understand the algorithms that you're going to use on the mechanism. So you have to generalize at least. Specialization is great because you can be an expert at something, but you do need that generality, which is why when you look at the curriculum for a robotics degree, you'll see it covers almost everything in technology.
Rich, it has been so eye-opening actually experiencing the shadow robot today, and I'm really excited for where your technology is going. Thank you so much.
Thank you.
Mission complete. Please evacuate immediately.
Okay, we are back at Mission Responsible HQ after our missions. Shinny, can you see a teleoperated robot changing the way that you help others learn?
Absolutely. I'm so excited about the technology I actually got to wear.
Yeah, I'm pretty jealous, actually.
It's so cool.
The idea that we're not even limited by human physiology as well. Like, we could have robots that have very different anatomy, different numbers of limbs even, and if you have that connection to your brain rather than you controlling a robot, combining this technology with other pieces of tech, like, machine learning models, so that if I'm thinking in a particular way, the multiple arms of this robot do a particular thing.
I didn't think of that. The idea that I could actually be like an octopus.
Yeah.
I mean, wow.
Would you want to... Of all the animals, is the octopus the one that you want to inhabit? Because you could be, the possibilities are endless.
Yeah.
Like, would it be an octopus?
I thought octopus just because it was a device that was on my hand, and then I was thinking, 8 hands.
Yeah.
Like an octopus. But you're right, I could have a third leg, 2 heads.
Wings.
So Simon, what did you get out of talking to Mischa? He's so impressive.
I really enjoyed talking to Mischa. I came away with a new understanding of the internet of skills, and I also came away with a whole bunch of questions. Like, it was one of those conversations you have where you tick it over in your head afterwards.
Intelligence accepted. Your final task is to brainstorm an idea for an upskilling gadget with Agent Cameron at D Branch.
Hello, agents.
Is the T-boy talking to us?
No, I'm Greig Cameron, Community Manager at DesignSpark. Dressed as a T-boy.
Hi, Greg.
Oh, I'd love a latte if one's going.
No lattes today.
Oh.
Right, so I want to hear your ideas for a gadget that will revolutionise how scientists and engineers learn new skills. It needs to be completely new, responsibly designed, and frankly, a bit mad. Who's first?
I can definitely do the mad bit.
I know.
My initial thoughts were, well, right now, we are working on technologies. I know that technologies are being developed where you can control devices with your thoughts. So it's the reverse of that. It's devices controlling your thoughts so that you can learn new skills.
Oh, I see. So it's like downloading, I want to learn how to fight Kung Fu. I will download kungfu.exe into my brain. The neural pathways will change and suddenly. But then do you think when you start using that skill, would you not know what you're doing? You feel like your body's just doing it without you consciously doing any of it?
Yeah, and I think what will end up happening is that there'll be some way of laying down synapses, a bit like how you would create a circuit board.
Yeah, the more you use the skills, the more developed the synapse pathways become, yeah.
So I don't think you will think that your body's being taken over. It would just feel like you just can do something without having to put all the effort in doing it.
So I go on the dance floor and my body's going absolutely wild. I have no idea what's going on. I feel like a passenger almost watching my body do the worm or whatever it is. Okay, so dancing is one application. I'm with you. What are other applications that we could use for what skills would you like to learn?
Learning a language.
Oh.
Yes.
Okay.
No more hours and hours of practicing your vocabulary or whatever it is that's really time consuming these days.
I like that idea. That could be one shared global language. So, Simon, what would be your idea?
I took inspiration for this from video games. So in video games, you have like a heads-up display where it will tell you what your stats are at that time, but also if you've got a mission that you're doing, where you're supposed to go. I wondered if we could have a contact lens that you would put in your eyes and would act as a heads-up display on your vision. So if you were navigating, for example, you could just see the path in front of you where you need to turn. But if you're learning a new skill, if, for example, you were solving equations on a whiteboard, it could give you a hint like they would in a game, like, oh, that's not quite right. You've gone wrong here, but I'm not going to tell you how. You could dial in the amount of support that you get. So it's like having in your vision a little tutor, a little teacher that just nudges you in the right direction.
It feels like we're in an era where machine learning and deep learning can do a lot of the intelligence for us.
Well, the pattern recognition, yeah.
Yeah.
And so so take that kind of technology and then put it in a near future contact lens, which then interfaces with a language model, say. It's like seeing matrix code, I've just realized. You're getting all the information all the time from everything around you. It's like you can see the source code of somebody else.
There's a lot to consider here between both your ideas. Potentially, they could be mashed together.
I was thinking that, yeah.
Let me give you an example, okay? With your uploading skills, you could potentially be a virtuoso guitar player. With your heads up, you could potentially be in your band of your choice. So, for example, the George Harrison of the Beatles. And you would be able to play everything that George Harrison's been able to play with the Beatles. Imagine how that would go.
Yeah, to your vision, you're on the stage at Wembley or wherever it is. I'd love that.
Really great discussion, guys. Thanks very much.
Thank you, Greg.
Thanks, Greg. How about that latte?
Still, unfortunately, not.
Warning, commence system shutdown.
Thanks for listening. If you enjoyed the show, please do one of 3 wonderful things for us.
That's right. We'd love it if you could leave a review, subscribe to the show, or recommend us to a friend. Or better yet, do more than one of those.
And don't forget, you can start your very own responsible engineering journey by signing up to DesignSpark's free design resources at DesignSpark.com. Until next time, I've been Agent Somara.
And I've been Agent Simon Clark.
And this has been Mission Responsible.
Mission Responsible was a Why Did the Chicken production for DesignSpark. Huge thanks to our guests Mischa Dohler, Kacper Rozansk, Rich Walker, and Greig Cameron. The series producer was Simona Rata, the researcher was Chris Armstrong, and the executive producer was Dan Page.